Hello and welcome back. In today's video, we will be doing financial mathematics, more specifically timelines. 5.7 is deposited into a savings account and 2 years later another 1.9 is added to the savings. A final deposit of 4.1 is made 5 years after the initial deposit. The interest rate for the first 3 years is 13% compounded quarterly, and it is then increased to 11.2% compounded monthly. Calculate how much money is accumulated in the savings account at the end of 8 years. Now, this question is quite complex, and in order for us to break down complex questions, we need an aid of a timeline. Let us go ahead and add our timeline. Now, once the timeline has been added, let us look at the components that go into our timeline. The first component would be the money component. We had a deposit of 5.7, which was the initial amount. 2 years later, we added 1.9. And finally, 5 years later, we added 4.1. Let's go ahead and add our components into the timeline. So a T0, which was the initial amount and the initial time, we added 5.7. And then 2 years later, we added 1.9. 5 years after the initial deposit, we added 4.1. Once that component is in the timeline, we focus on the interest rate component. For the first 3 years, we were dealing with 13%, and this 13% was compounded quarterly. Then we go ahead and add that to our timeline. Remember, the 13% was compounded quarterly, so it has to be divided by 4. Afterwards, the interest rate that came into effect was the 11.2% for the remaining years. And this one was actually compounded monthly, so we divide by 12. Once that's done, we can actually start adding this into our formula. Now A would be equal to P bracket 1 plus I close the bracket to the power of n. This is the compound formula. Once you are done writing the compound formula, you can start by calculating. 5.7 was actually affected by two interest rates. The first one would be the 13% compounded quarterly. You divide by 4 and then you raise it by 4. But for how many years? Well, this interest rate was only in the timeline for 3 years. It was then changed. Once it's changed, the only thing you have to do is just multiply the first interest rate with the new one. So it changed to 11.2% compounded monthly. So you divide by 2 and then you divide by 12 and then you raise it to the power of 12. For how many years? Well, for the remaining years, which is 5 years. Afterwards, we added 1.9, and this 1.9 was also affected by two interest rates. The first one was the 13% compounded quarterly, divide by 4, and then you raise it to the 4. For how many years? Well, this 1.9 was first affected by the 13% for 1 year, and then afterwards the interest rate changed. So again, when it changes, we only multiply the first interest rate with the second one. So we'll multiply that bracket with this bracket, which is compounded monthly, divide by 12, and raise it to the 12. For how many years? Well, for the remaining 5 years. As you can see, for the remaining 5 years, 11% was the one which was in charge. And last but not least, the 4.1. However, the 4.1 was only affected by the 11.2%. which was compounded monthly. Divide by 12 and raise to the 12. For how many years? Well, 1, 2, 3. For 3 years. If you whoop up your calculator, you would get a wholesome amount of 24,108,19. 8,000 is deposited into a savings account, and 3 years later another 3,000 is added to the savings. A final deposit of 4,000 is made 6 years after the initial deposit. The interest rate for the first 3 years is 12.5% compounded quarterly, and it is then decreased to 11.2% compounded monthly. Calculate how much money is accumulated into the savings account at the end of 9 years. Again, this is quite a complex question, so we need our timeline. Once the timeline is there, we need to identify our components. We need to start with the money component, our initial deposit of 8,000, followed by 3,000, which was added 3 years later, followed by 4,000, which was added 6 years after the initial deposit. We have to go ahead and add that on our timeline. The initial, which is T0, was 8,000. 3 years later, we added 3,000. And then 6 years later, or 6 years after the initial deposit, we added 4,000. Once that's done, we need to focus on the components, which is the interest rate. Now, for the first 3 years, 12.5% was the one that was playing around and in charge. And it was compounded quarterly, so you divide by 4. Once the 3 years was done, the new interest rate came into power, and it was there for the remaining amount of years. This 11.2 was compounded monthly, so we divide by 12. Once that is done, you need to write that into your formula. Now, we started with 8,000, and it was affected by 2 interest rates. The first one is the 12.5% compounded quarterly raised to the 4. For how many years? Well, it was subjected to this for the first 3 years, so you multiply it by 3, and then the interest rate changed. Now, once the interest rate changes, you just multiply the old one with the new one. Compounded monthly, so divide by 12 and raise to the 12 for the remaining years, which would be 1, 2, 3, 4, 5, and 6 for the remaining 6 years. Once that's done, we focus on the 3,000. It was only affected by the 11.2% because, well, after year 3, the 11.2% is the one that is in control. So our 3,000 was only affected by the 11.2%, which was compounded monthly. So you divide by 12 and you raise it to the power of 12 times how many years? Well, 1, 2, 3, 4, 5, 6. So for the remaining 6 years. And then finally, the 4,000 was also only affected by the 11.2% divided by 12 raised to the 12. For how many years? Well, for only 1, 2, 3 years. Once you have that in your calculator, you would get a wholesome amount of 34036.56.